about combining like terms. I first want you to consider a family at a restaurant, fast food restaurant, and this is their order. They get 2 burgers, a fry, and a drink, and 3 burgers plus 2 fries and 2 drinks. Now, in math, we often represent things with variables. So let's use variables or letters to represent this situation. So if I have 2 burgers, that's 2B. 1 fry would just be F. 1 drink is D. 3 burgers plus 2 fries plus 2 drinks. So this algebraic expression is representing the picture shown above. Now, wouldn't it be simpler if we put together the things that are alike? Instead of saying 2 burgers over here and then some stuff and then later on 3 more burgers, wouldn't it make more sense to just be like, hey, they got 5 burgers? And instead of just saying 1 fry here and later on 2 fries, doesn't it make more sense to say, hey, they got 3 fries? And the same thing for 3 drinks. So what we did here was we simplified a long math expression by combining things that were alike. We put burgers with more burgers and fries with more fries and drinks with more drinks. But what we cannot do is create a burger fry drink. That sounds disgusting. Okay, we have to keep the different things separate and only combine them if they are alike. For example, we had 2 burgers. Let me get my pen up. We had 2 burgers combined with 3 more burgers. Together, 2 plus 3 makes 5 burgers. They were alike, so we could combine them. Then we had 1 fry and 2 more fries over here. Those were alike. Remember, when we have just a variable with no number in front, it's like there's a 1 there. There was 1 of them, 1 set of fries. So 1 plus 2, of course, is 3. So altogether, we have 3 fries. And then we had 1 drink put with 2 more drinks. Well, 1 plus 2 makes 3, of course. So altogether, we had 3 drinks. So notice we combined the things that were alike but kept separate things that were not alike. And like I said, what we cannot do is say, okay, 5 plus 3 is 8, 9, 10, 11. We can't say we have 11 burgers because we don't. Or 11 fries. Or 11 burger fries because we don't. Again, we cannot combine things that are not alike. Okay, so now we are going to take notes. As I go through this, you are going to also write down onto your paper whatever I write on this video. So first of all, let's recall that multiplication shows how many times the same number is added together. It is also known as repeated addition. So if I have 5 plus 5 plus 5, isn't that saying I have 3 groups of 5 or 3 times 5? Let's double check the math. This is 10 plus 5 is 15. Isn't 3 times 5 also 15? Yeah, so that proves that we're right. Now, what if instead of a number I had a letter standing in place of that missing number? If I have G plus G plus G plus G, well, that's 4 G's added up. That's 4 groups of G. Or remember, when we're multiplying a number and a letter, we don't have to write the times sign between them. We can just squish them. So this is also 4G. Now let's get into a little bit of vocabulary before we do too much calculating. First of all, a term is a single part of a math expression separated by a plus or minus sign. So in this example, 3x is one term and plus 17 is another term. Let's go to the next vocabulary word. A variable is a letter used to represent an unspecified number or a value. For example, 3x. X is the variable in this situation. In this expression, we have x as our variable. It is a letter standing in place of some unknown number. Next, we have coefficient. Let's see if I can spell that right. Coefficient is the number that multiplies a variable. In this example, 3 times x, 3x is being multiplied, so 3 is our coefficient. Then we have blank is a term that does not have a variable. In this example, it's the plus 17. So if you have just a number with no variable attached, that is called the constant. Write these notes on your paper. Pause the video if you need to. Now let's define like terms. When terms are like terms, they are terms with the same variable raised to the same power. For example, if I had 5n, it would be like terms with, how about negative 3.2n? They are like terms because they have the same variable. Okay, we can combine them when they are alike. It's like burgers and more burgers. We're going to put them together. Let me do another example. I'll put or. Let's see. What if I had, how about a fraction this time? 3/5, I don't know, b, and how about just negative 7b? You see, they are like terms because they have the same letter. Why don't we put that under characteristics in the top right? Same letter. Okay? Just like burgers and more burgers, we can combine them. Now, notice this section says non-examples. A common misconception is for people to think that negative 4x would be like terms with negative 4y. But they are not. Notice this is the non-example section. They are not like terms because they have different letters. Let's make that note on our paper. They are not like terms because they have different letters. Again, pause the video if you need to catch up your notes. All right, let's check the bottom of our note page. It says circle every term that is like terms with 4x. So if it's 4x, I want the same letter. Let's see, does this have the same letter? Yes, let's circle it. No x, no x, no x, x. No x, no x, x. No x. So we did it. We found all three terms that were like terms with x. Next, I want you to pause the video and try to box in every term that is like terms with 1/2 a. When you're done, come back and push play to check your work. Now we're going to box in every term that is like terms with 1/2 a. Notice we're looking for a variables now. So 17 does not have an a, not like terms. Y is not an a, this does not have an a. 11a, there's one. Box in 11a, not an a, not an a, a. So these two terms are like terms with 1/2 a. Notice on the bottom right of our note page, we have a little reminder like I went through earlier in the video, how when we combine burgers with more burgers, we get a bigger amount of burgers. We combine the things that are alike, but keep them separate from the things that are different. Let's turn to the back of our notes. So, we aren't going to always see pictures of burgers and fries. We're going to usually see variable expressions that we need to combine. So, let's talk about how to combine like terms. Let's identify the like terms by highlighting or drawing shapes around them. You can see an example of that below, and we'll do it together in a moment. When you do that, make sure to include the sign in front. of the number. Okay, for example, the positive or negative plus or minus sign, include that. See how they included minus 12x so that we can see that it's minus or negative 12x? They included the plus sign in front of the 9 so we can see that it's positive 9. Okay, so second, you're going to rewrite the expression to group the like terms. Okay, so see in this example, they had 3x like terms with negative 12x. They rewrote them together. The negative 5x squared and negative 7x squared were like terms. They rewrote them together, and so on. Then finally, you're going to add or subtract the numbers and write your answer. So for example, 3 minus 12, well, you see how this is positive and this is negative? Same sign, add and keep, different sign, subtract. Keep the sign of the one with more, then it'll be exact. 12, 11, 10, 9, they are 9 apart. And there's more negatives than positives, so that's going to be negative 9x. So they did this part correctly. So one final step is to make sure they're in the correct order. We do want the final answer to be alphabetical order with higher exponents in front. Okay, so see how x squared term, the negative 12x squared term, moved to the front, and the negative 9x term was in the middle, and the constant is always in the back. So that single number there, he's in the back. All right, now let's do this one together. Okay, first we're going to make our matching symbols around the matching terms, the like terms. So if I first circle negative 12a, this is not an A, this is not an A, this is not an A. I need to circle negative 2a as well, because they both have a's, they're like terms. Now let's rewrite them together. Negative 12a minus 2a. You see how the sign in front connects to it. It's minus 2a minus 2a. Now let me box in plus 4b. This does not have a b, oopsie, but this does. So negative b is like terms with plus 4b. So let's write them together. And then finally, 7 doesn't have anybody to combine with. If you want to use another shape, sometimes I use a cloud, like on that example. Sometimes I use a heart. Sometimes I just leave it without a symbol. If there's nothing to combine it with, that's okay too. Sorry about that. All right, now we're ready to combine the like terms. So I'm going to put the A numbers with the A numbers. If I have negative 12 minus 2, if you need to go to the side, you can. And notice that this is negative and this is negative. Same sign, add and keep, different sign, subtract. Keep the sign of the one with more, then it'll be exact. This is same sign, add, and keep. That means keep it negative. So I'm getting negative 14a for the amount of a's. Now let me combine 4b minus b. Remember, when there's no number in front, I've got one of them. If you want to like put a little ghost 1 there or just draw a 1, you can. But the math you're doing to the side or in your head is just 4 minus 1. And that's simply 3. So this section is now actually 3b. And since it's positive, we need to put a plus sign right there. And remember, 7 did not have any other constants to combine with, so we just need to put it at the back. Now let me ask you, can I put burgers with apples? No, I don't want an apple burger, okay? We can't combine them any more than this. We are actually done. And let me check the final step. Are they in alphabetical order? Constant at the back? We did it, we did it. So this is our final answer here. Pause the video, make sure your notes are caught up with this. Now I want you to pause the video and try these 4 questions. Then come back to the video and check your work with me. Oops. All right, here we go. Let's check this one. First of all, I'm combining a 6r with a negative r. And some people like to go ahead and do that math right away. You can if you want to. 6 minus 1 is 5r. Now let me combine my plus 2b with my plus 4b. Those are like terms because they have the same letter. So 2 plus 4 is simply 6. So I have 6 b's. Now, are they in alphabetical order? No, they are not. We need to rearrange the terms. Make sure the positive is with the 6. But when I have a positive number in front, I don't have to put a plus sign anymore. I'm just going to put 6b. Oh, I just realized the 6 looks like a b. It's okay. Now, 5 is positive, so I need to put plus 5r. Final answer. How'd you do? All right, let's do the next one. All right, first set of terms are the I terms. There's that one and this one, and no more. So when I rewrite, I've got 14i minus I, and remember this is like 1. So 14 minus 1 is simply 13. 13 i's I have now. 13 i's. Okay, then let me look at the next term. I've got a 3 here, the constant 3 with no other things to combine it with, but I can't leave it out. I'm bringing it down. And then finally, let me do a cloud this time, I guess. We're going to cloud positive 9a and cloud negative 12a because they both have a's. They are like terms. Okay, so then let me be careful on this one because if I had $9 and I spend 12, I'm spending more than I even had. I'm going into negative town by $3. 9, 10, 11, 12. So this is actually negative 3a. Now for our final step, let's check for alpha order, constant at the back. The a term has to come first, and notice it was minus 3a, so that means negative 3a is in front. Then comes my positive 13i, and positive 3 constant is at the back. All right, let's see what's next. Okay, I've got j here and a negative 13j there. Oh my gosh, there's another j. Whew. I'm going to have to do a little extra math on this one. That's okay. Okay, and so this is 1. If I see no number in front of the variable, there's a 1. So 1 minus 13. Ooh, I better go to the side and be more careful on this one. Okay, first of all, if I have only $1 in my bank account and I spend 13, I'm going in debt by $12. But then if I get 5, I'm getting rid of a little bit of that debt, and now I'm only in debt by $7. So this altogether is giving me negative 7j. Okay, now I can see I've got to combine my negative 2w with my negative 7w, or you could say minus 7w. Now, if you want to go to the side, you can, and think about the numbers. This one, same sign, add and keep. So we're going to add up 7 and 2 to get 9, and keep it negative. So this is negative 9w. All right, let's check for alpha order. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So we are already alpha order. Done. Very nice. Okay, next up. Ooh, this one's special. An m squared, by the way, is not the same as an m. Let me tell you why. If you have an m times an m, that's what m squared means. Is that the same thing as just an m? No, it is not. Imagine these are numbers. Imagine I put a number in there like, I don't know, 3. This would be 3 times 3, which is 9. This would be just a 3. Those are not the same. So I'm telling you this to explain why an m squared is different than an m. You may as well treat them like different letters because they are that different. So let me find all of the m squared terms first of all. There's an m squared, no squared, m squared, no squared. Okay, so when I rewrite, 16m squared plus 4m squared minus 12m squared. Okay, so this is, I can kind of do in my head. 16 plus 4 is 20. 20 minus 12 is 8. So I'm getting 8m squared. Now let's check the m's. I've got minus 2m, same as negative 2m. Put with plus 4m. Ooh, those are different signs. Same sign, add and keep, different sign, subtract. When you subtract, you get 2. Keep the sign of the 1 with more, then it'll be exact. There are more positives than negatives, so this is positive 2m or plus 2m. Now, this is already in the correct order because we do alphabetical order when we can, and higher exponents go in front. Now, pause the video, make sure your note page looks exactly like this. Last but not least, it's time to apply your knowledge. Follow along as I read. A rectangular garden has a length of 5x plus 2 feet and a width of 2x plus 3 feet. A fence is being built to surround the perimeter of the garden. Draw a picture and write a variable expression to represent the total length of the fence. Don't know why there's 2 decimal points there. Pretend there's just 1. Okay, here we go. All right, so let's first draw a picture to represent the situation. If it's a rectangular garden, I'm going to need to draw a rectangle. And the length is this much, and the width is that much. So let me just label them. 5x plus 2 would be my length, and 2x plus 3 would be my width. Let me keep reading to see what to do now. A fence is being built to surround. That means to go around the perimeter. Remember, perimeter is the distance around a shape. So if we need to find the total length of the fence, that would mean the total perimeter. So perimeter is found by adding up the 4 sides. Side 1 plus side 2 plus side 3 plus side 4. Okay, so I already know this side here would be 5x plus 2. This width would be 2x plus 3. Now when I come to this side, of course it's a rectangle. Opposite sides are congruent. So this has to be also 5x plus 2. Let me put that in my little math problem. And then the final length, or width I guess it is, would be 2x plus 3. All right, so this is a really long problem. A great example of when it's helpful to be able to combine like terms. So let's put together all of the x terms first. Sorry, it's getting a little messy here the more I go. So if I do 5x plus 2x plus 5x plus 2x, I'm going to do a little mental math with you. The 5 and the 5 makes 10. Plus 4 more makes 14. Yo, this is 14x. Now let me add up the numbers, the constants. I've got 2 plus 3 plus 2 plus 3. 2 plus 3 plus 2 plus 3. Little mental math here. This is a 5 plus 5 more makes 10. So our final expression that represents the length of the fence, also known as the perimeter of the rectangle, is 14x plus 10. Pause the video, make sure your notes are perfect. Thank you so much for your attention today. Have a good day.